before we get into the material for today, what I want to do is kind of do a problem to give us some background information we're going to need to know. So let's say I wanted to solve 6x squared minus x minus 35 equals 0. And so I have a quadratic equation here. Probably the first way I might try to factor this, or solve it, is by factoring. And it does factor. This factors as 2x, 3x, factors of 35. I think I want a 5 here and a 7 here. So I get a negative 15 and a positive 14. That'll add and make negative 1. So then set those equal to 0 and solve it. So add 5. So 2x equals 5. Divide by 2. So one of my answers is 5 halves. Subtract 7. 3x equals negative 7. Divide by 3. And so my other answer is negative 7 thirds. Now the reason why I'm doing this example here is I want us to kind of look at these answers and then look at the original problem and see a connection between these answers and the original problem. And when I look at this, and I look at these numbers that are involved here, and I look at these numbers in here, I see that these numerators here, they're both multiples, or factors, they're both factors of this constant term. And when I look at these denominators, they are factors of the leading coefficient. And what we're going to say is that's always true if you can write your answer as a fraction. In other words, it's a rational number. Now, rational numbers can be integers as well. So like if you have negative 4, that's negative 4 over 1. So the negative 4 would have to be a factor of the constant, and the 1 obviously could be a factor of the leading coefficient, no matter what the leading coefficient is. So if we have any possible rational zeros for a problem, they have to be in the format of factors of the constant divided by factors of the leading coefficient. So it has to fit that pattern. Okay, so now we're ready to start talking about the material for this video. So I'm going to talk about the fundamental theorem of algebra. Okay, and what the fundamental theorem of algebra says, that if you have a polynomial of some degree n, highest power is n, then there are exactly n zeros and there are exactly n linear factors. So we need, in order to do this assignment, we need to know the following. We need to know how to come up with possible rational zeros. So what I just talked about. That factors of the constant divided by the factors of the leading coefficient. So that's something we need to know how to do. That's why I talked about it. We need to know synthetic division. Use that. We need to know the connection between x-intercepts, zeros, and linear factors. For example, if you have 3, 0 as an x-intercept, then x equals 3 is a 0, and x minus 3 is a linear factor. So that connection there, we need to know that. Now, one thing to note here, if you have an x-intercept, that means you have there's a real zero tied to that, and there's a linear factor. This doesn't necessarily work the other direction. If you have a linear factor, that means there would be a 0 with it, but that doesn't necessarily mean there would be an x-intercept. X-intercepts only occur at real numbers. So if you have a 0 that's not real, then it wouldn't have an x-intercept. So, but if it's an x-intercept, you do know that there is a 0 and a factor with it. So it goes this way, but not all the way the other direction necessarily. What else do we need? We need to know synthetic, quadratic formula. We're going to use that a lot today. And you know, it would be nice if you had a graphing utility, graphing calculator. And how to use it. All right, so, and we'll kind of go through that when we start working this out. So, on the assignment, what we're gonna do is we're gonna find all the zeros and the linear factors. Okay, so that's our goal. So let's say we have a function f of x equals x cubed minus 7x squared plus 17x minus 11. And I say, all right, I want to find the zeros. So what I would do normally is I would say, okay, let's set this equal to 0, and I'm going to solve it, and it's a third degree polynomial, so probably try to factor. So GCF, no, not everybody has an x, so GCF isn't going to work. Grouping, well, 1, 2, 3, 4, I got 4 terms. I might try that, but what I'm going to find out is grouping is not going to work because the coefficient, or the ratio of these coefficients, these first two, has to equal the ratio of coefficients of these second two. And since 1 to negative 7 isn't the same ratio as 17 to negative 11, grouping's not going to work. And then I have things like I could take roots, but when you have these middle terms, that doesn't really work. I might be able to treat it as a quadratic, but this one I can't because one thing I have 4 terms, and even if I had 3 terms, it has to fit a certain pattern where the first one has twice the power as the middle term, and so that's not going to work. And so at this point, we wouldn't have anything here. But there's, according to the fundamental theorem of algebra, there's got to be 3 zeros and 3 linear factors. So I need to kind of get my foot in the door somehow. And so what I'm going to do is I'm going to create a list of possible rational zeros here. So right now anything could work, and what I want to do is kind of narrow from infinity down to something that's a little bit more manageable. So I'm going to try this positive and negative 1, positive, negative 11. So I'm going to start with the factors of the constant term. So what numbers go into 11? So 1 and 11, positive or negative. And then over the factors of the leading coefficient. In this case, the leading coefficient is 1. So 1 over 1 is 1, and 11 over 1 is 11. And so, I only get these 4 numbers. Positive 1, negative 1, positive 11, negative 11. But, you could potentially have a long list of those. And then what I would do is I would start trying these and see if they work. Now, if I don't have a graphing utility, what I do is, I might just plug these in and see if I get an answer of 0, or I could just say, I'm going to start trying this. So let me try to see if negative 1 works, and I start synthetic dividing. So if x equals negative 1 is a 0, then x plus 1 would be a factor. That's the connection there. And so if I divided this by the factor of this, I can use synthetic division, and the number I'd put up there is the 0. So I'm gonna make a guess. I'm gonna say, maybe negative 1 will work. So I'm gonna try that. 1, negative 7, 17, negative 11. And what I'm looking for is a remainder of 0. So 1, that's negative 1, that's negative 8. That makes that a positive 8. That's a 25. That's negative, that's not 0. So that didn't work. And so I'd keep trying until I found something that works. Now, if I have a graphing utility, I can do this a little bit better. So let's say I go to my graphing calculator here, and turn it on. I'm going to go y equals, and I'm going to type in this formula. So this is my variable button, x to the power of 3. Move this out of the way. Okay. So x to the power of 3 minus 7x squared plus 17x minus 11, enter, and then I'm going to hit graph, and it's going to draw me a picture, And what I'm looking for is where does this hit the x-axis at? And it looks like it hits right here at 1. Now, if I want to be sure of that, there's a couple different ways I can verify that. One way is I can hit second, and then this says calculate, and I have some choices here, and I say number 2 says I want to calculate a 0. That's what I'm looking for. Calculate a 0 for me. So it would ask for left-hand boundary. So what I'm trying to do is figure out where on this grid do I think the 0 is. And so, you know, it looks like 1. So I'm going to pick a number left of that position. So I'm going to pick a number, let's say x is 0. And I'm going to hit enter, and it's going to ask me for a right-hand boundary. So I want to go past it, farther to the right, and I'll say 2. And I'll hit enter. And then it'll say, give me a guess. Now, you know, you can use this trace. You can kind of move around here if you want, make a guess, or you can type in a number here. So, you know, let's say I think it's like 0.9. I don't know. Maybe. I'm just going to make a guess. And what it's going to do is going to calculate it. Well, actually, it's at 1. 1 is where it's 0. That's what I'm looking for. Where is the y value 0? So 1 is a 0. And notice that's on my list. So I want to, let's see if I try 1. And again, if it works, then I know the remainder should be a 0. So let's see. 1 times 1 is 1. Add, that's -6. That's -6. That's 11. 11, remainder 0. Great. That's what I wanted to happen. So I have a 0. So this was not, that's not right, but the pattern still holds. So I have one of my zeros. Now what did that give me? That told me that I have x minus 1 times this result, x squared minus 6x plus 11. I'm still trying to figure out what makes that 0. So I have one answer. That answer is 1. That's what I just figured out. But I need to get the answers from here. And so I might try to factor that. It doesn't factor. Factors 11. That adding gives you 6. 1 and 11 make 12. Not going to work. But it is a quadratic. So that's why I needed to make sure I knew the quadratic formula. Let me use a quadratic formula. X equals negative b plus or minus b squared. B, that's a 6. 6 squared minus 4 times 1 times 11, a and c, 4ac, all over 2 times 1, so 2 times 1. And I'm going to work this out. So what do we get? We get 36, 4 times 1 times 11 minus 44. 36 minus 44 is the square root of -8. And square root of 8 is 4 times 2, so 2 root 2, and then an I because of the negative. So we have, so let's list out the zeros. My zeros are x equals 1, x equals, this is going to be a positive 6 divided by 2, so 3 plus or minus, well actually let me keep those separate. 3 plus 2 root 2 divided by 2, so root 2i, and x equals 3 minus root 2i. You'll notice these non-real answers, excuse me, those non-real answers, they're complex conjugates of each other, and that's always going to be true. As long as there's no i's in the original problem, then if you get a non-real answer, then its complex conjugate also has to be one of the answers to that. And then what I'm going to do is I'm going to rewrite this using the linear factors. So f of x equals, now how I get the linear factors, I think about, well, if I were to move this 1 over here so this thing would be equal to 0, that would be x minus 1. And if I move this 3 and this root 2i over, so that would be equal to 0, it'd be x, move the 3 over, minus 3, move the root 2i. If I move, same thing if I move this over, x minus 3 plus root 2i. And there it is. Those are all the zeros and the linear factors for that. So let's try another one of these. All right, so for this one, we're going to do the same thing here. I want to find the zeros. I want to write this as product of linear factors. So let's say we had this polynomial. 5x to the fourth plus 14x to the third plus 33x squared minus 36x minus 108. And so I want to find out from there. And I could make a list of possible rational zeros, but I'm just going to go ahead and go straight to the graphing calculator and use that and start typing this in. So 2x to the fifth plus 5x to the fourth, let's put that away, plus 14x to the third plus 33x squared minus 36x minus 108. So the reason why I do this because I thought maybe 108 might have a lot of factors, and then I got to divide them all by 1 and by 2, the things that go into 2. And so I just thought this might be faster. Let's just go to the graph, see what the graph looks like. And so we're looking for the x-intercepts. Now, this looks like it almost comes up and touches, but it looks like there's a gap there. To be sure about it, maybe I want to zoom in here and get this a little closer. And okay, it does hit at well, it looks like -2. I'm not sure if it is, and then hits over here, or whatever that is. So I said there's two ways. Two ways to figure out if a certain number is a zero. One, I could actually use the second calculate and 0, but the other one is I could do a value. Like if I eyeballed it, and I said, I think -2 is a 0. So I can do second calculate a value, and what that does is you type in the next value, and it'll tell you what the y value that goes with that is. So I think -2, if -2 is a 0, then I should get an answer for y of 0, and I do. So -2 is a 0, and then I want to figure out this one, and it's like somewhere in between there. I'm not exactly sure. So I'll do that calculate as a 0 option, and it looks like it's between 1 and 2. So I'll say, left of it is I'm going to say it's 1, right of it is 2, and then make a guess, and I'm going to say that looks like 1.5. It is 1.5. Awesome. That's right. Now, one thing I've noticed about these two zeros is there's a slight difference here. At this 1.5 spot, the graph crosses the x-axis. But at this -2 spot, it doesn't cross, it bounces off. Or in other words, it kind of acts like a little parabola here instantaneously. What that's telling me here is that this -2 is probably a double solution. I probably have -2 and another -2 as a 0, and then I have a single 1.5 or 3/2 as an answer. So, here I am. I'm going to say, some likely rational zeros, based on the graph, are -2, and I'm going to say -2 again, and then I'm going to say 1.5, 3/2. And so what I can do here is I'm going to start doing my synthetic division. And 2, 5, 14, 33, -36, and -108. And I'm just going to divide that like I normally would. So 2, that's -4, it's 1. That's -2, that's 12. -24, so 6, 9. -18, so 2, 4. -54. -2 times -54 is a positive 108. So that worked. And now, now what I'm going to do is I'm going to do my second -2 with this answer. So I'm not going to go back to the original problem. I'm going to say, well, I've already divided this by an x minus 2, and I've gotten, this other stuff, all this. So now what I'm going to do is I'm going to knock an x minus 2 out of that part. And then I'm going to get something, So I'm going to say -2, skip that. So 2, that's a -4, -3. That's going to be +6, so 18. negative 36, so negative 27, negative 2 times positive 54. Boom, that worked. And so now I want to use 1.5. I'm going to use 3 halves because it's going to be easier if I'm not using a calculator for me if I use a fraction. So 2, and so now what I'm doing is x minus 2, and now I'm going to do x minus 3 halves and something, So I'm basically just dividing out these things and getting a smaller result of the other part of my polynomial. So that's going to be 3, that'll be 0, 0 is 18, 3 halves divided by 2 is 9, times 3 is 27, so the remainder is 0. And now I have this, which is, remember I start with x to the 5th. Every time you divide using this synthetic division, you knock this down by a power. So I start with x to the 5th, now I'm x to the 4th, now I'm x to the 3rd, now I'm x to the 2nd. So now I have 2x squared, no x term, plus 18. And set that equal to 0. Now this one, it is a quadratic. I could use a quadratic formula, or I could just say, let's get rid of that 2, divide everybody by 2, plus 9 equals 0. And now I can take roots. I can subtract 9, x squared equals negative 9, take the square root, x equals plus or minus 3i. So zeros. I have x equals negative 2, and I'm going to say I have that twice. And I could write it twice, but I'm just going to write myself a little note here. There's 2 of them, so I'm going to write it twice. X equals 3 halves, x equals 3i, and x equals negative 3i. And so this f of x function can be written as, well, I need this 2 in here, so I'm going to put that on the front. And then I'm going to set each of these equal to 0. So I'm going to add the 2 over, so x plus 2. I'm going to subtract the 3. Oh, wait, there's twice. I almost forgot that, so it's squared. And then subtract the 3 halves, so x minus 3 halves. And then subtract the 3i, so x minus 3i. Add the 3i, x plus 3i. So that's how you do finding all these zeros in these critical values.